Hello everybody, this is Mr. Bowman. So today we're going to be looking at solving a linear equation with several occurrences of the variables on both sides, and fractional coefficients on Alex. Alright, so looking at what we're doing here. Remember, anytime we start with fractional coefficients, it is often easiest to try to get rid of those fractions in step 1 to try and make your life a little bit easier. So looking here, we have denominator of 2, 5, and 2, so we really only have two unique denominators. So I'm just going to multiply those together to get a common one. So 2 times 5 is 10. So I'm going to multiply everything in here by 10. So multiply both sides of my equation by 10. All right. So then, since there are two terms on both sides, I'm going to distribute that 10. So I end up sending it to all four terms in my equation. And when I'm done, I should end up without any fractions. So looking here, I have 10 times negative 5 halves, so I want to reduce, because remember this is 10 over 1 for both of these. So if I reduce these, it's going to give me slightly smaller numbers. So 10 and 2, if I cancel both of those out by 2, I end up with a 5 and a 1, so it's just 5 left over. So 10 divided by 2 is 5, I guess is another way to think about that. So 5 times negative 5 is negative 25w, and this is a normal number, so it's easy enough, 10 times 4. And then over here, these are both fractions, so I'll cancel them both. So 10 over 5 is 2. Negative 6 times 2 is negative 12w. And then here, 10 over 2 is 5. So 3 times 5 is 15. Now, I have variables on both sides still, but I have no fractions. So I'm just kind of easing it down to simpler and simpler terms here. So I'm going to go ahead and add 25w to both sides. Okay, so I end up with 40 equals negative 12 plus 25 is 13. And I didn't do anything with this negative 15, so I'm just going to bring that down. And that's actually what I'm going to do now. I'm going to add 15 to both sides so that this adds up to 0. So it's just gone. So I'm left with 13w on that right side. And then I have 40 plus 15, which is 55. And then last but not least, I'm going to divide both of the sides by 13 so I can cancel out that multiplication. So 55 divided by 13 doesn't come out super nicely because 13 is a prime number and 55 is not divisible by 13. So I'm just going to go ahead and leave it as 55 over 13. All done.